Hello everyone and welcome back again. In this session we'll start looking on the aggregate and the classification of the aggregate in more details. And previously we have discussed the concrete ingredient and we have seen that concrete is made of cement mixed with water and aggregate. These are the three basic material to produce or to make any concrete, and we need to study the properties of each in concrete ingredient in more details. We're discussing how this material can affect the concrete properties or the concrete durability in general. So, as we discussed before, this is the concrete mixtures. Concrete is made of cement, made of water, made of sand, together with the gravel or the coarse aggregate. And it can be seen that majority of the concrete is aggregate, sand and gravel. Sand is the fine aggregate, a gravel is the coarse aggregate. And together the fine and the coarse aggregate both are considered as aggregates. So majority of the concrete volume or the concrete mixtures are made of aggregates. So the fine and the coarse aggregate generally occupy in the range between 60 to 75%. So the 60 to 75% of the volume of the concrete are aggregate. So this is a high percentage of the concrete volume that is coming from the aggregate. And this is in terms of the weight. In terms of the mass or the weight, the concrete or the aggregate is occupied in the range between 60 to 78% of the total concrete weight. So 70 to 85% of the weight of the concrete is coming from the aggregate. That's why this is a high percentage of the aggregate contents or the aggregate percentage in the concrete. This one will strongly influence the concrete fresh mix and the hardening properties, the durability of the concrete. So because majority of the concrete volume and majority of the weight of the concrete is coming from the aggregate, that's why aggregate will strongly influence and strongly affect the fresh and hardening properties of the concrete. That's why we need to be more selective when we are using the aggregate to be used in the concrete production. So aggregate must conform to a certain standard for the optimum engineering use. They must be clean, hard, strong, durable particle, and free from any absorbed chemical or any other fine material that could affect the hydration process or the hydration reaction and the bond between the cement base and the aggregate particle. That's why this is because aggregate is occupied majority of the aggregate or the concrete volume or the concrete weight. Today we'll start discussing the classification of the aggregates in terms of the different perspective. The first one is in terms of the particle size, and we'll discuss the classification in terms of the source of the aggregate, in terms of the particle shape, the textures of the aggregate, and the unit weight of the aggregate. So starting with the particle size, the classification of the aggregate in terms of the particle size, we can categorize the aggregate into two groups. The first one, the aggregate can be either fine aggregate or it can be coarse aggregates. This is the classification of the aggregate in terms of the particle size. And any particle size of the aggregate that is higher than 4.75 millimeter, we call it coarse aggregate. And the aggregate that has a particle size lower than 4.75 millimeter, we call it fine aggregate. So if we have like, this is the particle size and this is 4.75 millimeter. The aggregate has a particle size higher than 4.75 millimeter higher, we call it coarse aggregate. And the aggregate has a particle size lower than 4.75 millimeter, we call it fine aggregate. So this is the differentiate between the fine and the coarse aggregate. The fine aggregate is actually the sand. The coarse aggregate is represent the gravel. So this is the first classification of the aggregates in terms of the particle size. So in terms of the particle size, the aggregate can be either coarse aggregate or fine aggregates. How to differentiate between both is the particle size. 4.75 millimeter. The higher is the coarse, the lower is the fine aggregate. And here is this is the coarse aggregate, this is the fine aggregate. Both of them are aggregates, but this one has a particle size lower than 4.75 millimeter, and we can call it fine aggregate, or you can call it sand. And this is the gravel, which has a particle size higher than 4.75 millimeter. The second or the other classification of the aggregate is the source of the aggregate. It can be either crushed aggregate or uncrushed aggregate. The crushed aggregate is simply the stone or gravel that is coming after the crushing process. There is a crushing process. We go to the mountain, we have a big rocks, then we start to crush these rocks into small particles. So after the crushing process, we had this aggregate that can be used in the concrete production. This, this type of aggregate, we call it crushed aggregate. The other source is uncrushed gravel or uncrushed aggregate, which result from the natural rock. And this is how it looks. The uncrushed aggregate, which has smooth surface, rounded surface that we haven't do any crushing process, or we don't apply any crushing process to these kind of aggregates. And it can be, you can differentiate between the crushed and uncrushed. The crushed, this is how it looks. The crushed aggregate, which has rough surface, sharp, broken edges, in which the uncrushed or the natural aggregate are come in a smooth surface, rounded, because we haven't do any crushing process to this one. So these are the different sources of the aggregate, can be either crushed or uncrushed. And here is some feature or some property for between the crushed or uncrushed, or between the crushed one and the natural one. Normally the crushed aggregate here, which has sharp broken edges with rough surface, this is as a result of the crushing process. Actually, it processed from natural rock. It has sharp angular particle from quarry, rough surface. The particle itself, it will be rough, relatively rough compared to the uncrushed particle. It has a good bond strength. The bond between the particle size, because we have discussed that concrete is mixed with paste, paste mixed with aggregates, and the paste is act like a glue that glue all the aggregate particles, bond all the aggregate particles. So this bond, it can, we might have strong bond, good bond, or weak bond between the aggregate and the paste. So the bond here, the type of the aggregate, the source of the aggregate, it will affect the whether we will have a good bond or have weak bond. So the use of a crushed aggregate that has rough surface, sharp broken edges, it will result in a good bond with the paste. In which the uncrushed aggregate that had a smooth surface, rounded surface, it will result in a low bonding properties. So if we compare between the crushed or uncrushed, the crushed aggregate particle, this one that has rough surface, sharp, broken edges, it will result in higher bond properties than if we compare it with the uncrushed particle of aggregate. In terms of the workability, the uncrushed or the crushed that it has a rough surface, sharp broken edges, it will result in a low workable concrete compared to the uncrushed when we use the rounded aggregate. So this is a difference between what we are expecting when using this one and what we are expecting to use this one. The use of crushed aggregate will have a good bond with the cement paste, better bonding compared to the uncrushed. In terms of the workability, the use of the crushed that has sharp broken edges, it will result in a low workable concrete compare of the mixes containing the rounded or the uncrushed aggregate. So this is one of the influence or one of the effect of the aggregate properties on the concrete properties. So this is how the type, the source of the aggregates will affect the concrete mix design or the concrete quality or the concrete properties, whether fresh or hardened. Another classification of the aggregate can be classified based on the shape, based on the textures. So the aggregate, after the process of crushing, it will come into different shapes and sizes and different shapes. It can come either in rounded shape, irregular shape, angular shape, flaky, or etc. So these are an example of different shapes of the aggregate after the crushing process, and any aggregates that as a result of the crushing process it will come in a rough surface compared to the natural aggregates. There is another classification of the aggregate in terms of the unit weight, how heavy or how light is the aggregate. They can come into three different groups. It can be either lightweight aggregate, normal weight aggregate, or heavy weight aggregates. So how to differentiate between the light, the normal, or the heavyweight is based on the unit weight or the density of the aggregates. The standard, they specify the range of the lightweight aggregate, and they have mentioned that if the aggregate has a unit weight or density in the range between 750 up to 1,100 kilogram per cubic meter, then we start to call it lightweight aggregate, and it will result in a lightweight concrete. The normal weight aggregate has a unit weight or density in the range between 2,150, it can go up to 2,500 kilogram per cubic meter, and this is the range that when we are start calling it normal weight aggregate. And the aggregate that has a unit weight or density in the range between 4,000 up to 8,500 kilogram per cubic meter, they will start to call this as a heavy weight aggregate. So in general, what we have taken a quick recap of today, the why it is essential and why it is important that we need to be selective of using aggregate in the concrete properties, because majority of the concrete are aggregate. Majority of the volume of the concrete is aggregate, and the volume can go up to 75% of the total concrete volume is aggregate. That's why aggregate, small change in the aggregate properties, it will make significant change or significant effect on the concrete properties. That's why we need to be more study the properties of the aggregate that we are using, and we have studied the classification of the aggregate. We can classify the aggregate in terms of different criteria based on the particle size, based on the source, based on the shape, textures, and the unit weight. For the particle size, we have fine aggregate and coarse aggregate, and 4.75 millimeter particle size is the differentiate between the fine and the coarse. In terms of the source, we have crushed and uncrushed aggregate, and here is the difference between both of them. In terms of the shape of the aggregate come in different shapes. It can come in rounded, irregular, angular, flat, etc. And these different shapes as a result of a crushing process. In terms of the shape textures, it can be either come in a rough surface textures or smooth textures. Or in terms of the unit weight, it can be either a lightweight aggregate, normal weight aggregate, and heavyweight aggregates. And the differentiate of all of them is the specific, on the unit weight or the density of the aggregate. So we stop here and we'll see you in the following session.